Okay, so today we're going to examine properties of parallelograms. So we looked at the classification of parallelograms from their sides when they were equal and their sides when they were parallel. Right? And one of the things that we should have noticed, let's go back and see if I can find that. So when we looked at this classification of parallelograms, right, by parallels, we should have noticed that parallelograms have squares, rectangles, and rhombi all in the same classification. Right? They are all the same. In this case, they were the same circle. They were the same country, whatever you want to think of it. All right? Then, when we looked at them from sides that were equal, we said parallelograms were here. And again, rectangles, squares, and rhombi were in that classification of parallelograms. So parallelograms contain a lot of the different quadrilaterals, which is why we're going to look at those properties of parallelograms. And one of the things we're going to look at is the diagonal of parallelograms. So if we have a parallelogram, right, the diagonal is this line that goes like that. Okay, so this segment that goes from one opposite corner to another, or from one opposite vertice to another. That's what a diagonal is. And you've heard the word diagonal a lot. In fact, when they talk about TVs and their size, they lengthen on the diagonal. All right, so that's what a diagonal is. All right, so here's what we're going to do. Go into, all right, so whether you're on a Chromebook or a computer, whatever it is, all right, you're going to go into my website, all right, and once you get there, we're going to go to Geometry Unit 6, all right, so maybe pause the video and wait till everybody is on this page. Okay, so Unit 6, we're going to go there, and we have two things we want to look at, parallelograms Part 1 and parallelograms Part 2, all right. So I'm going to click on parallelograms Part 1, and here we go. So this says, use the parallelogram below to perform the following constructions and measurements. There's a lot of things here. Number one, measure the slope of the sides. What do the slopes tell you about the opposite sides? So you should measure the slopes of the sides. Remember, you can accomplish that if you go to the angle thing, right down here, slope. All right? Point to the middle of the side, you'll get it. Measure all four sides. What do you notice about the sides? Okay? Measure them. Measure all four angles. What do you notice about the angles? Construct diagonals BC and AD and the point of intersection. Label the intersection point P. So then you should go to a segment, right? Go from one opposite corner all the way over to the other one, right? And that would be your diagonal. And then you would measure another diagonal or draw another diagonal, right? Measure the diagonals. Measure the distance CP, BP, AP, and BP. What do you notice? So remember, P is the distance. Here, let's put this here. Let's go from here to here. All right, we want to point an intersection right there, and that's going to be my P point. All right, I can't right-click and change it to P on my tablet very well. But that's what that is. So that would be P right there. All right. Now, if you need to pause it and go back and look at it, go ahead and look at this. But that's what we're going to do. So that's going to take you a little bit of time. You have a lot of measuring. Some of the things you're going to look at this and say, yeah, I already knew that. I know that. But that's just part of reaffirming what we know. Okay, using the GeoGebra to reaffirm what we already know. So that's good. Once you have that information, and this would be something you should record in your notes because you can't record it in your GeoGebra thing. Write it down in your notes, okay, what it is you notice. Then we'll go back and go through it. Okay, so you should have noticed. Let's make some conjectures of what you would have noticed. All right. My screen looks pretty cluttery. Hopefully it's what yours looks like. First of all, we measure the slopes of the sides. What do we notice about the slopes of the opposite sides? So we notice that no matter how we move this parallelogram around, right? Okay. What do we notice about the slopes of the sides? And no matter how I move that, these slopes are staying the same. Okay. No matter how I do it, those slopes are staying the same, which means that those opposite sides are parallel. That's right. Okay, good. Which we knew that. I know, we're just reaffirming. Measure all four sides. We measured all four sides. What do we notice about the sides? What measurements are the same? Opposite sides are equal. Again, this is something that we knew. We're reaffirming. Okay. All four angles. What do we notice about that? So we measured all four angles. All right. I notice here, this one here is 86. This is 86, 93, 93. Opposite angles, they are equal. No matter how I change this parallelogram, and that's the important part that you need to understand, is that when you take a shape and move it, if it always happens, then it's true. As soon as we move it and something goes a little bit off, and we know there's something wrong. Okay, so when you're going through and doing the Google Classroom questions, and you're going to have a test question where you're going to have to figure out, what kind of a parallelogram or what kind of a quadrilateral you have by looking at the measurements, and what looks like might be isn't necessarily true. So you have to move things around a little bit to check to see if it's always going to hold. Okay, you got to do that. That's why we're doing this whole thing. All right, so. Construct the diagonals, BC, DC label point intersection P. I did that. Measure the diagonals. So what I noticed when I measured the diagonals, AD here and BC here, they were pretty close in measurement, but in actuality, they aren't. All right, so they aren't quite the same, although they're pretty darn close, right? So if I make this thing look a little bit more like that, I get a little bit more difference in my diagonals from 21 to 27. Okay, so the diagonals aren't equal. Well, that's not very interesting. But look at the distance from A to the point in the middle, P, and they call that D here. And the distance from here, or to E, I guess, from E to D, okay, which in your case should be P, because I told you to label it P. All right, notice that those two distances are the same. And the same thing as we go from C to here and from B to there, also the same thing. So when we have two segments and they cut each other in half, we have a terminology for that. Right? You might remember what that is. All right? What do those segments do to each other? Okay. So what we want to do then is record all this stuff, make sure we get it in our notes, right? So we want to say that a parallelogram, all right, in a parallelogram, right, we already know opposite sides, right? Opposite sides are equal and parallel. Know that. Opposite angles are equal. Okay? We know that. If we draw the parallelogram out like this, all right, we call it KRST. Then these diagonals that I'm going to draw here and here, then we don't know much about those, right? In fact, they're not equal. However, if we put a point here and we call that point P, then we know that RP, right, is equal to or congruent to PT. So, same thing's going to happen here, here. Same thing's going to happen on this side, right? So then the diagonals are bisected. They bisect each other. So that means they're cutting each other in half. That's what that means, right? That's what we've talked about before. We talked about bisected from the second or week of school, right? What bisect means, cutting things in half. Parallelogram, those diagonals bisect each other. They're not equal, but they bisect each other, okay? So when we start looking at parallelograms, remember, in each cases when we classified them, not only does this hold for parallelograms, but what other shapes should have the same properties that this does. All right? What's one of the shapes that should have the same property? Well, rectangle, square, rhombus. Right? According to both classifications, these are parallelograms. All right? So, since these are parallelograms, they should have the same properties as we set up here. Opposite sides are equal. Parallel and parallel, okay? Opposite and equal, I don't know why I didn't put the word angles in there. Opposite and equal angles, all right? The diagonals here bisect each other, right? So that should also happen in these other three shapes. And if we go back to this, right, we know that we can take this and rearrange it, right, so that it looks like a rectangle or it looks like a square. I can make this come over here and get pretty doggone close to where it looks like that. And we can look at our diagonals, okay? AD, here's our diagonal, right? In this case, they're almost exactly the same length, okay? And they still bisect each other, right? They're still bisecting each other. So yeah, it does work out. Opposite angles. They're both 90 degrees, so they're still equal. Opposite sides. They're equal. Opposite sides. They're parallel. So it holds up the same way. And all I would have to do to get it to be a square is just get this position correctly, right? So there's almost a rhombus that we had right here, right? Okay, that's almost a rhombus, I bet. These sides are pretty much the same, all right? And sure enough, there's my diagonals. Sure enough, they bisect each other, all right? Sure enough, if I look at it good enough, I can see if I move this stuff out of the way, here's 39.42, there's 39.42. Those opposite angles are equal. Here is, looks like 140, and over here, I bet if I moved all that stuff, I would see that probably is 140. I'm trying to get that CB out. There's the 140. I'm covering it up right there. I can see that it's 140. All right? So opposite angles, opposite sides. But in this case, it's a rhombus, so all the sides should be the same. Okay. And we'll explore that a little bit more when we get to, particularly to rhombi. All right? But I wanted to make sure you understood that. So just in parallelograms, here's the properties that we have, okay? So, what I want to show you next is this. So let's say we have a shape. I'm trying to get this thing to work here. That has markings. Look like this. And we have parallel here, and we have parallels here. The question is this a parallelogram? All right. Now, when you are doing these problems, it is very important that you do not look at the figure, but you look at the markings, okay? You got to look at the markings. If the markings fit, then you're good, all right? Because we're going to try to mess you up a little bit by drawing a shape and then put marks on there. You're looking at it and go, hey, I think that's definitely a parallelogram because it looks like a square. But yet the markings do not back that up. So we want to make sure we're looking strictly at the markings. here we have parallel lines here and parallel lines here. Opposite sides are parallel. So I go up to my parallelograms, and I said, sure enough, opposite sides are parallel. That's going to give me my parallelogram, okay? So then I would say, yes, this is definitely a parallelogram, okay? Yes, it is. Let's look at one like this, all right? Here we go. Put a right angle there, put a right angle there. Is this a parallelogram? Well, I've got two right angles. It looks like a rectangle, but these angles over here, I have nothing marked there. I have no idea what those could be. All right, so I'm not sure about that. If these two form 90-degree angles, and I know these are parallel, all right, but I don't know anything else about any of the other sides. I just had this here and this here, knowing that maybe these are going to be parallel. This is only going to be one side's a parallel, one pair. That's not a parallelogram, all right? And if you think about it, because we don't know anything about these other sides, we could swing this out to here and look, definitely not a parallelogram because we don't know anything about that side, all right? So then we would say, no, this is not a parallelogram. So when you're doing these problems, you have to look at the markings and look back at your definition and check to see if it works or not. Okay. One other thing about the diagonals in a parallelogram that we should talk about here. Here's a parallelogram, okay, and here is the diagonals. All right. If we measured this angle here and this angle here, you would find out that they are the same. Okay. If we looked at this angle here and this angle here, we would find out those are the same. And we might want to say, well, why is that? Well, let's take a look at this. All right. So here is one side of the parallelogram, correct? Here is a diagonal. Goes all the way down to here, we'll say. And this is the other side of the. I'm just going to kind of extend this out a little bit. And I'm going to extend this out a little bit. Okay. So hopefully you kind of see that I have duplicated this drawing right here. Here's my two sides. Here's my diagonal. Okay. So we're talking about this angle here being the same as this angle here. Why is that? Why is that? What do we know about this line here we'll call L and this line here that calls M? Comes from the parallelogram. What do we know about it? We know they're parallel. And when we have a line, such as this, okay, that cuts that two parallel lines, right, we have some special angles there, don't we? Okay, we have to think back a little bit, think back a little bit more, all right? What do we know? We know these angles have special names, okay, and what they're called. And then we also know that they're equal, okay? Same thing here. Same thing here, all right? So hopefully you're getting that. Hopefully that Miss Knudsen, I know she knows the name of those angles, so she can help you with it if you don't, okay? So you're going to need that information when you get to do your assignment, all right? Before we do that, though, I remembered there's quadriparallelograms part 2, all right? So we want to go check that out. Now, this is one that I didn't write, but it's kind of cool in that it shows you the different things you just discovered, okay, by doing this nice little slide here, okay, and looking at those hey, look, there's a translation, right, that's showing you, hey, this is a parallelogram, and that works, all right? So what you should do is just take a few minutes to look at each one of those, all right, just to verify again what we've been learning, okay? Okay, hopefully you paused that, and you were able to spend a couple minutes on that. When you do the assignment, okay, we're going to throw out a couple problems here I see I don't want us to do. Okay, gosh darn this thing. All right, so on the assignment, in the very first, there's 6 questions. I don't want you to do 4 through 6. we're going to cross those out. Okay, 4 through 6, don't do them. All right, the rest of them are fair game. There is a bubble proof at the end. It's been a while since you've done one of those. See how you do on it. Okay, I'm interested to see how that goes. The rest of it should be okay on. Okay, so don't forget, you got to turn your project in today. If it doesn't allow you to turn it in, please put everything on the paper or on another sheet of paper, all the measurements of things that you did. So, for example, you could say segment 1 and the grade, and you would write down what the grade is. Say it's 4%, whatever it is. Segment 2, whatever grade that one is. Say it's 5%, whatever that is. Okay, list that out. Do the same thing for the other questions. Okay, you can answer them in Google Classroom, but if it's not allowing you to turn it in, it isn't going to help me any or help you. I also need a picture of your map. So here's the map, and here's the trail, and I need a picture of that. So take your phone out, take a picture, send it to my email. Okay, so you got to send it to rogerp@sthelens.k12.or.us. All right, you have to do that. Make sure you send that picture to me, and also kind of put your name in there so I know who you are. Like some people I get emails from, and they have some crazy name. I go, who the heck is that? So put your name in there so I can see that. Because I got to see your trail, all right? And then I need to see the answers to the questions. So if it doesn't allow you to turn it in, I don't know why. Some people are getting the turn-in option, some are not. We're currently trying to figure it all out. We're working on going to contact Google and figure out what's going on. But anyway, for now, that's the best I can do for you. Okay? All right. So make sure you turn that in. Otherwise, we'll hopefully see you Monday.